My name's Andrew McMillan, and I'm a consultant contracted to coordinate the Carbon Watch component of, the grasslands component of the Carbon Watch program. And so this is not about nitrogen, but we've heard all day about nitrogen-carbon interactions. And David's very kindly accommodated me in the program, and thought it'd be a good opportunity to highlight where this program is going and what it's all about. There's a lot of overlap with the MB program that's been the focus of today in terms of the people involved, in terms of some of the gear involved, and in terms of some of the questions. And so it's a component of a wider MB program that's led by Sarah Mikaloff Fletcher at NIWA, and she's actually online today. And what I thought I would do is give an overall outline of the overall Carbon Watch project. And it's not something I'm an expert in, but if you have questions in that component, Sarah can come in and help answer them at the end of this. And then I would focus on the portion of that program that I'm coordinating, and the grasslands component, and talk about how it fits into the overall program, and kind of give highlights of the work streams. This part of the program is still very much in the developing and ramping up stage, so it's really kind of giving you a flavour of what this part's all about. So Carbon Watch itself is a 5-year MB program, and we're into the third year of it now, and it's a program that's kind of based around atmospheric measurements and modelling to understand the entire New Zealand carbon budget from a top-down approach, but sort of using bottom-up techniques to validate, and I'll go into more of that later. This is a fantastic photograph. Sarah has provided me the first few slides in here, and this is Rainbow Mountain, just south of Aotearoa, and it's a station where NIWA's got some instruments to measure carbon dioxide, and you can see just in the background the variety of different ecosystem types. And what I'm going to talk about first is the sort of overarching kind of goal of this is to use an approach called inverse modelling to infer the fluxes of carbon dioxide right around the country. And you'll probably all be familiar with this plot, which is the rise in atmospheric carbon dioxide concentrations that are measured at Bearing Heads, NIWA's main sort of clean air measuring station. And this plot that you're looking at has been heavily filtered. You'll see the current number on the Stuff website, 413 parts per million this morning. And it's been heavily filtered because they are only choosing the concentrations of CO2 that they measure coming straight in from clean air, not over land. But actually, one thing that is really driving this project is the fact that there is so much more information that they collect that isn't necessarily used for background air, but depicts CO2 concentrations as they've been influenced by the air travelling over land. And you can see that there are many concentrations of CO2 higher, in which case the land has contributed carbon dioxide to those concentrations, or lower, in which case the land's taken away CO2. And this is another slide that Sarah's given me, which is a fantastic little movie of atmospheric circulation. And New Zealand's particularly well located for this kind of study where you're using atmospheric transport to work out how carbon dioxide or how air parcels with carbon dioxide concentrations get transported to the measuring stations. Right now that you're looking at wind coming in, and this might be collected as clean CO2, but you can also see how the air is travelling over the land, and the land is either adding or taking away carbon dioxide. And if you've got clean air measuring stations at well-selected locations, for a long time, NIWA's had the Bering Head and Lauder Station. As part of this program, they've also added one up at Rainbow Mountain. And you can see that by measuring carbon dioxide and knowing something about the transport, you can infer what is where CO2 fluxes are coming from, or you can map CO2 additions and subtractions. And so it's very much along the same lines as perhaps what Johannes just showed in terms of footprinting at a particular location, and this slide just shows 1 hour of measurements. You can take back trajectories and kind of work out a sort of probability field of where that air is most likely to have come from, and then you can expand that over a year and create sort of fields of influence right over the country. And then from that type of data, you can attribute sources and sinks to various regions of the country. And what you're seeing here is preliminary analysis of inverse modelling showing the degree of sinks across the country, and one notable area that the team's influenced is quite a marked sink in southwest New Zealand. So that's a very tantalising finding, suggesting that there's quite strong carbon sequestration going on in that portion of the country. I won't go into that too much today, but one of the, we've already heard about Winchmore, but one of the other stations that the NIWA team are putting in this year is a station at Winchmore and these are simulations of the influence of different parts of the South Island to Winchmore. So you can see that Winchmore would be receiving information from the Canterbury Plains, from the West Coast, from the ocean to different degrees. But that's one of the new atmospheric CO2 measurement stations. And so I want to make a distinction between the Eddy Covariance sites, which we've heard about today, which measure the movement of CO2, and these kind of things which measure the concentration field. So just to make that clear. And so here's a kind of overall summary picture of the overall Carbon Watch program, in which we're looking at CO2 exchange from forests, from farmlands, and from urban environments. And these indicate stations located to pick up the concentration at measurement, different places. And the high-level components to Carbon Watch are forestry, which Miko Kirschbaum is leading that component, the urban emissions, which Jocelyn Turnbull at GNS is leading, and I'm sort of coordinating the grasslands component in collaboration with, I'll go into the collaborators in a second. The urban story uses not only CO2 measurements but other traces to indicate fossil fuel emissions. And there's efforts at the moment to use carbon dioxide and other traces and ocean-based measurement to estimate carbon uptake in this area of interest in Fiordland. And then there's a grassland component, which is centred around an Eddy Covariance network, so leveraging off of all the historical and current Eddy Covariance sites that have been funded by many different programs, but notably MB and NZAGRC and other sources of funding. And it's in contrast to the top-down inversion modelling. This would be bottom-up measurements, so measurements made up on the ground, working out fluxes from particular areas, and the programs revolves around kind of the communication between those two different forms of measurement. So you have the atmosphere with these sort of receptor stations and knowledge of atmospheric transport, but it turns out to be an under-constrained, poorly constrained problem. So you need, in this kind of Bayesian type approach, you need some kind of first guess or some estimate of what the bottom-up fluxes are. And that's what the idea of the Eddy Covariance stations are. These, we've heard this several times today, but measure the balance between photosynthesis and respiration by measuring net ecosystem exchange directly. So that's just what they're measuring. We've also heard it called net ecosystem production, or NEE, so there's different names for more or less the same thing. And these are just the fluxes from the surface to the atmosphere. They don't include all those other carbon terms like export of product and all those type of things. And I won't go into this, since I think we all know that Eddy Covariance is sort of measures the turbulent fluxes of CO2, and with two particular instruments to measure both. If you measure the motion and the concentration, you can get at the exchange. We have a lack of coverage. This is a network at the moment of the Eddy Covariance stations within the program, and there's obviously a sampling density problem. They're expensive systems to set up, 100,000 probably, at least a FTE of time to keep one going, and they do rely on having flat topography, which most of our country is not, and we do face this also this problem that most of the Eddy Covariance systems have been located in high intensity systems, either high intensity Waikato dairy pasture and irrigated, non-irrigated high intensity dairy systems in Canterbury. So the solution to this conundrum of poor sampling density is to model the CO2 fluxes using an ecosystem model and to parameterize that ecosystem model using data from the towers that you do have. And so Liz Keller is ingesting, at GNS, is ingesting the data from the sites, from the network of sites, and she is providing that initial estimate that feeds into the inverse model. And the second solution is to extend the sampling range of the Eddy Covariance measurements, so to extend the range into low productivity systems. So the first of those is been going since 2019, funded by this program, Eddy Covariance site, just at the farm right next door to the Lauder atmospheric station, and that's maintained by Dan Smale. And then later this year, we're going to put in one at a much lower productivity place just up the road from there. So this is very arid central Otago property with a stocking rate of something like 4 stock units per hectare. So basically, this is what the whole program, if you want to put it in schematic form, looks like. A inverse modelling component with atmospheric measurements and good knowledge of atmospheric transport, prior estimates of CO2 flux that are provided by the Biome BGC model, and data for calibrating the model from the Eddy Covariance network, plus the additional biophysical data that you would need to drive an ecosystem model. And so that would be the top-down and the bottom-up components, and this is a part that's the grasslands component here. And so just to give you some idea of what the kind of work streams in Carbon Watch grasslands are, is the ongoing operation of existing Eddy Covariance sites within that have been developed within the program. So that would be the Lauder and the Methven site, as well as this new one that's coming in this year. And this slide just gives you an idea of the total extent of the sites within the program. So you can see that they're mostly concentrated around intensive systems. And in all, there's about, now I think I counted 57 site years of data as of last year, so we're probably up over 60 now. And we've seen also a lot of plots about carbon exchange, and I realised that since I've worked previously both at NIWA and Manaaki Whenua, I have both an atmospheric approach where you plot carbon as a negative quantity when it leaves the atmosphere. So these plots on the top left-hand side depict monthly, for each month, the average diurnal pattern of net ecosystem exchange, which can be partitioned into the respiration component in red and the photosynthesis component, as I've labelled GPP up there, into green. And this plot kind of depicts the seasonal variations at Lauder over a 2-year period. Sorry, no, that's just for 2020. And so this kind of provides, in one look, a real good idea of the extent to which photosynthesis or respiration is driving the net ecosystem exchange and what the seasonal variation would be. And this plot on the lower right is a cumulative carbon exchange plot, so shows a balance. And in this plot, I've gone the other direction, or used the other convention, where negative numbers mean a loss of carbon from the ecosystem. So I've got my ecosystem hat on for that one, and it's and down the lower half is weekly totals of rainfall, and without doing a comprehensive analysis, it's tempting to look at the big rainfall events and see that a change in direction of the carbon. As soon as it rains, you start reaccumulating carbon into the system. So preliminary results, but that's after having this site established for just on 2 years now. So it's a medium intensity beef site. So the second site is going in to this area, and it's it doesn't look so much like that here, but if you look at the Google map, it's a very arid ecosystem, and we're hoping to have that as soon as the gear comes down to us. It's stuck up in Waikato at the moment because of COVID, but we're hoping to have that going in by the end of the year. And so what is going to continue throughout the course of this program is having continued ingestion of more and more Eddy Covariance data, and so the predictive ability of the model will get stronger. And this is just a presentation, just bits of a presentation that Liz Keller gave at EGU a few months ago, showing the use of her ecosystem model. So it's a BioBGC, but it's been modified with collaborators from Hungary to allow sort of the modelling of pastoral systems in the same way that we heard that Epson did today and Miko's KenW model. And so she's using an approach by which she's using certain sites to parameterize a model and then testing the model on other sites. And I won't go into all the components of the model, but the sorts of model observation agreement are shown here, where she's getting reasonable model agreement for NEP, GPP, ecosystem restoration, and ET. And ET always seems to be quite good as far as model data agreement goes. And so this just shows every data point for every half hour across the network of sites. So one of the other things that's happening in this program is that Jordan Goodrich at the University of Waikato, in collaboration with Louis Schipper and Aaron Wall, is taking that group of data sets and creating a synthesis study exploring how the relative influence of management versus climate, and in particular trying to tease out the influence of drought on carbon exchange and the extent to which carbon is lost from events beyond the farmer's control, like drought. And just very preliminary data here, just looking at sort of seasonal rainfall for the sites within the network, and noticing a decrease in NEP, and this is less carbon going into the system as you go down, with increasing amounts of rainfall. I thought rainfall made plants grow. A little interesting, but his analysis combining in radiation with it suggests that at this time of year, the greater the rainfall, the more the cloud, the less light. So it's not immediately intuitive what the controlling factors are. And so Jordan's going in and exploring sort of weather trends using NIWA station data at different regions in New Zealand, and sort of ultimately wants to kind of work out what the implications for carbon exchange on farms given trends in climate data will be. And then finally, Scott is going to be looking at remote sensing proxies of pasture growth and possibly also Eddy Covariance variables using Sentinel imagery, Sentinel-2 imagery, and working out using a combination of the metadata, things like pasture clippings from different stations, as well as the Eddy Covariance data, and sort of looking at the relationships between remote sensing proxies and those data. So in conclusion, the value of the grasslands component includes this ability to calibrate biome BGC, but and the synthesis we're hoping will help aid decisions to manage carbon, especially looking at those short-term climatic variables and ways in which you can prevent carbon loss or work out the level of control you have. And then I just also want to emphasise that the act of collating all this data will have uses that extend beyond just the ability to validate the model. For example, they also measure water vapour flux, and so the applications, and of course you'll all be aware, extend well beyond carbon. And and then there's the possibility in here of, once you understand those short-term responses to weather, that gives you much enhanced ability to look at the longer-term responses to climate change. So thank you very much, and it's been a really nice opportunity to come down and present this stuff to you. I just realised I didn't show the full list of collaborators. So Scott Graham, John Hunt, Johannes Laurbach from Manaki Whenua, Jordan Goodrich, Aaron Wall, Louis Schipper from the University of Waikato, Dan Smales, Brent Williams, Patrick Butler, Mike Harvey from NIWA, and Liz Keller from GNS.